Hello friends, this is our operating system class. In previous class we have already learned 6 CPU scheduling algorithm. The last one is the round robin algorithm. The 7th one. Now the 7th one is the multi-level queue scheduling algorithm. In multi-queue level scheduling, at a ready state there is a multiple queue. Like in ready state there is a multiple queue and all queue have different priority level. Let's say there is a 3 queues having multi-level, 3 queue having different priority, and in each queue there should be a similar or dissimilar types of scheduling algorithm used, which we have taught in previous classes. So on the basis of the priority, these process will be executed. This queue ready queue process will be executed. Means that if the first queue is get high priority, then first queue process will be executed first, then the second queue, then third queue on the basis of their priority. Here on the priority there are two types of priority based. The first is fixed priority but preemptive scheduling method, and the second one is time slicing. What is fixed priority preemption? In fixed priority preemption, if we have a 3 ready queues, means that let's take example, we have a 3 ready queues, one for system process, one for foreground process, and the third one is background process. Out of which, if we do system process with high priority and foreground with low priority and background process with low and low priority, means third level of priority. Now if the system process is running on the CPU, means that this queue's process runs in CPU. After completion this queue, after completing this queue, the process are in foreground process queue will be executed. But here the preemption, due to which if any system process comes in the system process queue, then this running process which are from low priority will be preempted and high priority queue process will be executed, because now there is a one process come in higher priority queue. So there is a preemption if okay, means that here the preemption is applied. Now the time slicing. In time slicing, what happens? In time slicing, if there is a multiple queue, there is a 3 number of queue, so each queue have given equal or different types of different time slot. Means that the algo 1 get a more priority, it get 2 seconds for execution, it get a 1 second of execution. This is a 0.5 second for execution, means that algo 1 get more priority according to priority wise, and this is called time slicing scheduling. Okay, now here the example, there is a 2 queue. In first queue there is a round robin, and the second queue in which FCFS is follow. Here with example there is a 4 process from 2 queues 1 and queue 2. Okay, now the first high priority given by round robin process. So first P1 will execute, then P2, then again P1, then again P2, then P3. Here P1 and P2 have burst time 4 plus 3 7. After 7 unit time, the P3 gets chance for execution. But when P3 is executing 2 unit of time in P4 comes in higher priority queue. That's why P3, which is running on FCFS algorithm, but FCFS is not a preemptive algorithm, but But in high priority queue, P4 process comes, so the P3 process will be preempted and P4 process will be execute. So the disadvantage is that the low process, some process may starve the CPU. Means the starvation is happening here, because if the high priority queue won't get empty, if the high priority queue are never becoming empty, then the next queue which are having low priority will not get a chance for the execution. It is not inflexible. If flexible नहीं है, means that the process can't shift it from one to another queue. Means that if the process is in Q2, then it in Q2, which is low priority queue, is not shifted to the Q1, which is a high priority queue. These are the disadvantages of the multi-level queue. Now the eighth one is multi-level feedback queue scheduling. In multi-level queue scheduling is that there is a 3 queue having different priority level, but the advantage is here that we can shift the process according to its priority wise. If some process is getting starvation from long time, then this process will be shifted to the high priority queue, so that it can get a chance to execute. So this provides flexibility for the process to shift from low priority to high priority to low priority, according to the need for execution of the process or waiting time, different things. Okay. Now here the analysis of the scheduling algorithm. So we analyze the algorithm on the basis of some factors and the algo. So first one, the minimum average wait time among non-preemptive. Among all non-preemptive, SGF having minimum wait time. SGF, shortest job first get, minimum wait time. The minimum average waiting time among all, here for non-preemptive, here for alls. So SRTF get minimum average wait time. So in non-preemptive, always which process have non-preemptive nature in always. So the FCFS is a non-preemptive, SGF, LGF, HRN, non-preemptive, priority, algo. These are the non-preemptive in nature always. And preemptive always, no one process is preemptive always. In some conditions, every process become non-preemptive. In some conditions, every non-preemptive algo become a preemptive. Like in previous one, multi-level queue, if the process is not preemptive, but if the new process comes in higher priority queue, then process will be preempted. SRTF behave as a SGF, shortest remaining time first, behave as a shortest job first. When the all process arrives together, and when later arriving process won't have burst lesser than the remaining time process. In these two cases, SRTF behave as a SGF, shortest job first. As we know, shortest job first is a non-preemptive and SRTF is a preemptive algo. The preemptive priority behaves as a non-preemptive, when preemptive priority behave as a non-preemptive. When all processes arrive together, same as above, when all processes arrive together, and when later arriving process won't have priority higher. Means that when preemptive priority behaves non-preemptive, when the preemptive algorithm behave as a non-preemptive algorithm, when Simply when if letter arriving process have not do not have a higher priority, then why the process will be preempted? Because the upcoming process are not having higher priority, so it won't be switch context switch. What happened? Okay, then the round robin behave as a non-preemptive. As we know, round robin is a preemptive algorithm. So when q is max, quantum is max burst time of all process, then it happens RR round robin we have as a non-preemptive. The conway effect, where conway effect happens in FCFS or LJF, always know that. The starvation, in which algorithm starvation will occur? SJF, shortest job file, SRTF, priority base, LGF, RDF. Okay. Here in round robin quantum, in round robin, if the Q is high, quantum is high, then there is a process and there is a context switch time, and the process, then context switch time, then the process. So to find the efficiency of the CPU, what do we do? Here the context switch, here the context switch time and the quantum time. So to find the utilization of the CPU or efficiency of the CPU, here the how much time CPU will execute and how there is a total time. After adding context switch time into 100%, we will get the efficiency of the CPU. If there is a n times process execution, then we will add n and n minus 1 context switch time, number of time context switches happens. Now here the CPU utilization same happen without input output operation. The CPU utilization will be 100%. Now if there is a input output operation, what happens? Here the process get into the input out operation state. Now at that time CPU was the ideal. Then at 20 seconds, after 20 seconds, another P2 process comes in CPU. So in 0 to 30 second, 0 to 30 unit of time, there is a 10 unit of time at which the CPU is idle. Okay. So the P is a fraction of time required for the input output of process. P is a fraction of time. If we take a 10 unit of time out of 30, this is a P. From 30 out of 30 we require 10 time for input output of process. So if there is one process in CPU, then the CPU utilization is 1 minus P. CPU 1 minus P. P is a time which he consume in waiting time or input output operation time. So the CPU utilization happens only from 0 to 10 and 20 to 30. So the 1 minus P. If there is a 2 process, then it's become 1 minus P2. If n process, then it become 1 minus P to the power n. Okay, thank you. If you want to download the notes, it will my Telegram channel link is in description.